In linear regression and in calculating related concepts like correlation coefficients and the coefficient of determination, one has to first take one's data and create a bunch of summary statistics, like the sum of x and the sum of y. Oh, and then take those summary statistics and put them into some rather elaborate formulas. This particular problem, the key to it is that first step, one has to take one's data and create summary statistics, has already been done. Let's take a look. A media company is investigating the relationship between movie ticket sales and book sales. Oh, now, I know there's a lot more to read, but I want to stop here for a second. The relationship between movie ticket sales and book sales. Okay, so it's implying that it's collecting two sets of data, movie ticket sales and book sales. Sure enough, the company has gathered information on 30 movies that were based on published books with a total, okay, and then there's this other information, total movie ticket sales of a lot, $7,058 million, 3-year book sales of each movie's corresponding book total. Now, it's not talking about any individual movie and its book. It's talking about adding them all up together. All the book sales, they add up to that. All right. When each movie ticket sale is squared and these numbers are summed together, you get this really large number right here. Okay. While squaring and summing together the corresponding 3-year book sales results in this not as large, but still pretty big dollar amount. Multiplying each movie ticket sales by its 3-year book sales and then summing these values together equals that number right there. Okay. Now, finally, the question. What are the correlation coefficient and the coefficient of determination for this hypothesized relationship in movie ticket sales and book sales? Okay. So, to work this particular problem, we have to calculate the correlation coefficient and its cousin, the coefficient of determination. First, let's lay out the actual formula for the correlation coefficient. Why? Because it essentially is going to provide us with a shopping list of all the various things that we need to complete it. Okay, now it's quite complicated. The correlation coefficient, this one. The traditional symbol is rho. Looks like an lowercase r. It's a Greek letter, rho. What does the formula look like? Well, it has a numerator and a denominator. In the numerator, you're looking for n times the sum of x times y minus the sum of x times sigma for sum, the sum of y. Okay, that's just the numerator. In the denominator, even more complicated, essentially has two parts. So why don't we put some square brackets here for, I'm working on the first part. N again times the sum of x squared. You square each of the x's and then you add that all up, minus the sum of x. You add up the x's first, then you square them. That's a different result. Okay, end of a little square bracket, meaning that's one part. When you're done with that, you want to multiply it by this. You want to find this. And again, times the sum of y squared. Square the y's and then add them up, minus the sum of y. Add them up first, then square them. Okay, and a little square bracket, because that's another component. That times that. Oh, wait a minute. The denominator still isn't finished yet. One of the things we have to remember about it is in the denominator, all of this is under one big square root. All right, now, we complete that formula right there, we have found the correlation coefficient. And that is exactly what the question was asking for. Okay, now we need to go shopping. Now first off, I kept writing this x's and y's. What are the x's and y's? All right, there's a hypothesized relationship between two things. Those are the x's and the y's. Now, which one is which? Because we have movie ticket sales here and book sales. All right, x is the independent variable, y is the dependent variable, y is the thing that we are assuming depends on something else or can be predicted by something else. Now, do you notice in the original situation, I mean, why would they be doing this analysis? They're trying to see if the 3-year book sales, you know, a book comes out and it's around for 3 years, would predict the movie ticket sales. You know, then they make a movie. That makes the movie Y. The book or book sales X. Oh, all right, so that's what my Y's and my X's mean in this particular case. Now I need to go looking for all of these other pieces because I'm not provided data on specific movie sales or specific book sales. I'm just provided data on all these interesting, their summary statistics. For instance, let's just comb through this. The company has gathered information on 30 movies. Perfect. Perfect. Found it. I'm going to make little notes to myself here. Got to stay organized. Lowercase n equals 30. Right, in this formula, n is the size of the sample. It's like the size of the data set that you're working with. And they said, well, they were comparing book sales to movie sales, and they looked at 30 instances because they looked at 30 movies, n equals 30. Found it. All right, so we know that'll go there and there and there. We can check that off our list. Now, let's keep going here. Where total movie ticket sales were 7,058 million. Wait a minute. Movie ticket sales are Y. Total movie ticket sales, add up the movie ticket, add them up, that's sigma. We just found sigma Y. We just found the sum of the Y's. All right, now I'm not going to bother to write the millions. I'm already pretty dazzled by these numbers. So we'll work in millions. Okay, the sum of Y equals 7,058. We found it. 3-year sales of each movie's corresponding totaled. We were just saying, oh, the book sales are X, and they total up to that number. The X's total up, summation X, to that number. I'm just copying it down. Okay, got that one. When each movie's ticket sales is squared, okay, we were saying, well, movie ticket sale would be Y squared. Okay, that's what that would look like. What about it? When each movie ticket sales is squared and these numbers are summed together, sum of Y, you get this really large number that I need to copy down, 1,885,412. Okay, got it. While squaring and summing together the book sales, X for book squared, squaring and summing them together, the sum of X squared is 551,300. And then another fact, multiplying each movie ticket sales by its 3-year book sales. Multiplying each Y times its X, and then adding them all up, that's the sum of X times Y that's being described to me. What does that equal? Ooh, 872,000. I'm just copying the number down. 486. I'm working in millions. Oh, I think we have everything we need now to fill out this formula. And we just read it out of the problem. It was actually just being reported in the problem. Okay, so at this point, all we need to do is just be neat and stay organized. Let's piece together, in the case of this particular media company, what the correlation coefficient would be. What we're going to do is copy that formula over again, except substituting the appropriate values. Okay, so in the numerator, it would be 30 times, the sum of X times Y was down here, 30 times the 872,486 minus the sum of X is 3,136 times the sum of Y was that 7,058. Now remember, you would do your multiplication first and then you do any addition or subtraction. That would get you the numerator. The denominator, all right, the denominator first, this part right in here. Okay, 30 times the sum of x squared. That's 551,300 minus the sum of x, 3136 squared. So remember, do the multiplication first, then do the subtraction. That's that half. Save that number. Okay, on the other half right here, it's the same 30 for n times the sum of y squared, that's that great big number, 1,885,412, minus the sum of y was 7058. We want to square it. Remember, do this first and this first, then subtract. When you have those two results, then multiply them by each other. Oh, right, and wait. All that, then you want to take the square root before you declare it the denominator. All right. If you want to track your calculations along with mine, what my calculator shows is that the numerator, if you've done this, remember the multiplication first, then the subtraction, I get 4,072,052. That's the numerator. And then in the denominator, 6,725,716. All right, now if you disagree with me, be careful probably what went wrong, because this is a complicated formula. Is remember, you always have to do your multiplication first, then your addition or subtraction, right, within the, always reducing the parentheses and then moving outwards. All right, anyway. Oh, so what's that actually come out to? I get 0.60, although depending on how many decimal places you stored for when you took the square root, this is kind of a tippy problem in that you might be looking at on your calculator, for instance, 0.605 for some odd. You go, well, isn't that 0.60 or 0.61 if you wanted to round? True, just depends on how many decimal places that you intended to keep. It's essentially the same discovery. That is the correlation coefficient. Took us more than a few minutes to find it, but that is the correlation coefficient. What is that indicating? It's indicating that there's a fairly strong positive correlation between 3-year book sales and then movie ticket sales for any given book that's made into a movie. Which means, and this makes sense, that the more the book sold, the more the movie is likely to sell. Okay, now wait. The problem asked, what's the correlation coefficient? Oh, it's that. And then what is the so-called coefficient of determination? And you might be thinking, great, now we got to do another formula. The coefficient of determination, it is a very close cousin of the correlation coefficient. It is r squared, or rho squared. It's this result squared is called the coefficient of determination. So I would take this and square it. And for instance, if I put that right there in my calculator and squared it, I would get 0.36. That would be the correlation, or excuse me, the coefficient of determination. You might have 0.0367. It depends because of the square root and the dividing, how many decimal places that you chose to keep. Okay, that's the other half of this determination. Okay, and if you're asking, well, other than answer the question, why do we do that? This is the so-called r squared of the linear relationship between the movie ticket sales and the book sales. The idea with the r squared, the coefficient of determination, is, let me think, this is the proportion of variation in the existing data that is explained by the linear regression relationship between movie ticket sales and book sales. About 36% of the actual variation in the data that we can't even see, it's those 30 movies, is explained apparently by this linear structure.